Hi, this is Alex from devstories.eu. Mastering Modern Pandas, Episode 4 of 8. You have a multi-gigabyte Parquet file with 100 columns. You only need 4 of them to run your metrics. If your first move is to load the entire file into a data frame and then filter down the columns, you are wasting massive amounts of RAM and CPU cycles before your analysis even begins. The fix lies in mastering modern data ingestion. The primary bottleneck in data ingestion is disk input and output. Pandas read functions like read_CSV and read_Parquet scan data from disk into memory. To minimize this transfer, you use an argument called useCalls. You pass a list containing the exact column names you want. The parser reads only those specific columns from the file. The performance gain you see depends heavily on your file format. CSV files store data row by row. When you use useCalls with a CSV, the parser still has to scan through the entire text file row by row, but it immediately discards the unneeded columns before allocating memory for the data frame. Parquet aisles, however, store data column by column. For a 100-column Parquet file where you only need 4 metric columns, passing useCalls means the parser completely ignores the file blocks holding the other 96 columns. It reads only the bytes it absolutely needs from the disk. This drastically reduces both your read time and your memory footprint. Restricting columns is only the first step. The next optimization happens in how Pandas stores those columns in memory. Historically, Pandas relied entirely on NumPy arrays. NumPy is excellent for dense numerical computation, but it struggles with text data and missing values. It stores strings as scatter Python objects in memory, and it forces integer columns to become floats just to represent missing data. To solve this, Pandas introduced the dtype backend argument. When you set this argument to the string pi_arrow, Pandas uses Apache arrow to back your data instead. Arrow stores strings in highly efficient contiguous memory blocks and uses a separate bit mask to track missing values, keeping your integers intact. Here is the key insight. You might think Pandas reads the data into NumPy arrays first and then converts them to arrow. That is not what happens. When you specify the pi_arrow backend during the read function, Pandas bypasses NumPy entirely during the parse phase. The data flows straight from the file on disk into pi_arrow arrays in memory. This avoids the severe performance penalty of intermediate memory allocations. Let us look at the full pipeline. You call read_Parquet. First, you pass your file path. Second, you pass useCalls with a list of your 4 metric columns. Third, you set the dtype backend argument to pi_arrow. The parser jumps directly to the 4 columns on disk, extracts them, and streams them straight into arrow-backed memory. You end up with a lean, lightning-fast data frame holding exactly what you need, backed by modern data types. Restricting columns at the I/O layer instead of the application layer is the single most effective way to prevent out-of-memory crashes in Pandas. That's all for this one. Thanks for listening and keep building.